We're undergoing a major bleaching event here in the Bocas del Toro archipelago. Now a lot of people are asking me, well, what is a bleaching event? What does that really mean? So I kind of wanted to take this opportunity to explain what happens when coral bleach. And to do that, I have to give you just a little bit of background on coral. Coral, we generally think of them as the complex formations that are in the ocean that create a lot of the beauty and a lot of the textures in the sea. What they consist of are little tiny animals that form a colony, and we call it a coral colony. All of those on that formation comprise that colony. So each one of those little animals then is, for oversimplification purposes, interconnected through that skeleton. And they make their skeleton by collecting calcium from the sea. So those little polyps, each one of them as an individual, then gathers up or allows to grow algae inside their skin, between the skin and their ectoskeleton, which they create from the calcium. So in normal conditions, that's what gives the corals their color. When the conditions get somewhat stressful in some way, whatever it is, that changes the way the algae react with that symbiotic relationship they have with the polyps of the coral. And in normal situation, what they do is they create oxygen and sugars and share that with those polyps, with the colony, which is all interconnected. So it makes for a very healthy environment and a great way for the polyps to be fed and provide energy. They have tentacles. Almost all of the polyps on all the different kinds of corals have tentacles that they can extend and capture food. But they can't generally capture enough food to support the whole colony, so that algae situation really works as a powerful tool for them. Well, instead of, when it gets hot and there's a lot of sunlight, what happens is that instead of producing the oxygen and sugars, they produce hydrogen peroxide. And that's a toxin for the coral. So as soon as they sense that, they expel that algae away from them. And what you're seeing then, because their skin is translucent, clear, you're seeing clear through to the ectoskeleton, which is made of the calcium, which is white. So that's a bleaching. The whole colony turns white. That doesn't necessarily mean that those polyps, the coral itself, is dead. What it does mean is it's undergoing tremendous stress. And if those stress conditions lessen up over a certain amount of time, there's a possibility that they'll recover. But if it lasts, if it persists, then that colony is going to die. And a coral community is made up of hundreds of colonies, which is then made up of thousands and thousands of the polyps. So the temperatures throughout the Caribbean, and in fact through a whole band along that latitude in the world, has recently undergone temperature changes that are extreme. We've been measuring temperatures here in the archipelago, and at all depths they're from 88 to 90 degrees. And that's way above what coral can sustain. They developed their systems over hundreds of thousands of years, and things are changing very rapidly for them. So they're not having time to adapt. In a situation where that, and even in this situation, given enough time, there will always be some survivors. And those survivors, given enough time, another 200,000 or 300,000 years, will recreate something that resembles what we had 20 years ago. Probably radically different for all practical purposes, but something will be here. What coral restoration tries to do, all the practitioners try to do, is collect enough of the survivors and propagate them so that we can create a seed bank and begin helping them exchange those traits among each other, the ones that survive, that have the strength to survive, so that we can speed evolution up. And in general, it's working. The technologies, the methodologies have been being increased and more efficient very rapidly. What we are doing here in the archipelago is we're collecting as many of the survivors as we can, of as many genotypes as we can, and then placing those on coral trees. And then we put the coral trees in a situation where they're relatively protected. In this case, we've had to move a lot of the trees into deeper water so that they have less sunlight for the algae to react to. We've made shades over the trees for the same reason. But what we've done is we've taken some of each of those genotypes and put them in individual nurseries scattered throughout the archipelago, so that when they spawn naturally, those egg and sperm from each one of the different genotypes will mix. And hopefully then those prodigy, if you will grow and be a stronger type of coral. With a major bleaching event like we've just had, that's it's kind of a sign, a warning that we don't have enough time for that to happen. We're probably talking about 20 to 50 years before that program, a program like that, would have enough effect that it could begin spontaneously reproducing stronger coral. Well, the conditions of the sea are probably not going to change that rapidly. So a technology now exists where we can take the corals from the ocean and take them into a controlled environment, and when they spawn, collect the egg and sperm and keep it till it combines, makes the larvae, and then attaches to something, and keep it in that controlled environment until it becomes of a nature that can survive in the waters that persist. So there is hope, and it's actually exciting to see how fast those technologies and that progress has become. But it's also extremely eye-opening when I go out into the sea and look at, we have all of these places in the archipelago. There's 22 places in the archipelago where we have documented where the last surviving staghorn corals are in the archipelago. And this last Sunday we checked over half of them to see what their condition was, and in about 75% of them there were no survivors already. So we did the math on what we knew was there. We did the math on what we estimate is probably the losses, and came up with a number that, and then doubled it so that we were as conservative as possible. And we suspect that in the Bocas del Toro archipelago, of those very important corals, there may be as few as 200 surviving. at this point. So what we're doing right now is of utmost importance. We know for sure that we have several of the genotypes of that species in our nurseries, and they are the last survivors of that genotype. So anyway, that kind of brings you up to speed, I think, on what happens with coral, what we're doing, and anything that you can do to help is absolutely appreciated.